So data types is one of those things where unless you're like just a big dork, you probably don't care, and you could be a really big dork in a lot of ways that are really important and still really not care, and that's okay. But if you've ever complained about a computer game and you're like, oh my god, why is this so slow? You should care about data types. Because lazy programmers are generally fine, because most of what we're doing, none of this like is going to matter, because we're not making giant programs where it's like, going to be gigabytes and gigabytes and gigabytes. Like the craziest program I've ever written in Matlab is still probably measured in the kilobytes size. It's not really big. So even if I'm super efficient, if it goes from 30 kilobytes to 16 kilobytes, nobody cares. If it went from 32 gigs to 16 gigs, then somebody might care, but that's not what I'm doing. If you, however, do become like a bigger, fancier programmer, this stuff becomes more important. And just for the purposes of not looking stupid in front of other programmers, this is the kind of thing you should at least kind of somewhat know about it. So if you don't already kind of have this set up with the layout in the default, I would say go ahead and do that so that you have the workspace here just to make sure you see it. So under the workspace where it says name and value, right click and make sure you also have size, bytes, and class selected. I don't really care about the value. I guess I will in a little bit. But name, value, size, bytes, and class, okay? So normally we've run stuff just like setting up one or a matrix or a vector. And this is what we've seen. So we can come in here and be like, okay, there's my stuff. I've done things. I don't know why X is down there. I must have an X down there. Yeah, I have an X down there. So I've got A has a value of 1. And if I look over here, it says it's a class double. Everything's double. So MATLAB just automatically makes everything a double. And what double means is double precision. And the reason it does this is that gives you the maximum. Okay, everything I'm saying is with a giant asterisk before someone's like, well, technically, shut up. This is good enough for government work. A double is the most precision you're going to get without trying super duper hard. So that's what we're doing. And by precision, I mean it's going to save a whole lot of information to make sure that whenever you say 1, it's like, okay, for realsies, she like legit means 1. Okay, so basically what that means is in base 2, you're representing the number using 64 bits. So there's 8 bytes. So there's 8 bytes times 8 bits per byte, 8 bits per byte. So that's 64 bits. Okay, so you have 64 bits. So those are ones and zeros. There's 64 ones and zeros that are storing this information. So even though it says 8, that's 8 times 8 is 64. There's 64 ones and zeros storing this number 1. Now here, there's 80 because each one of those numbers in there is stored as a double. Each one of those numbers is stored as a double, and then this is stored as a double. So even though this is a complicated, obviously, that's pi, that's a more complicated number, also stored as a double. So it takes just as much work to store the number pi as it does to store the number 1, but MATLAB is assuming if you're not going out of your way to declare what your variables are in advance, then obviously you don't care that much. Other programming languages like C, C++, you have to declare your variables in advance and be like, this is going to be a double, this is going to be an int, this is going to be a char. It's super annoying, but actually really good for you. And that's how you write good code. We're not writing good code, we're writing functional code because we just want to do stuff. We're not trying to, we just want to automate stuff so that we don't have to like do stuff by hand. That's all we're trying to do. We're trying to just move forward. So basically, MATLAB is working overtime so you don't have to. So again, you can kind of see, like, if I'm working just to store the number 1 as I am to store the number pi, I'm not being very efficient. But like I said, who cares? This isn't a big deal if you're programming in MATLAB. This is a big deal if you're coming out with like a super high-tech video game with lots of graphics and blah blahs and blah blahs and whatevers. So, you know, like in Super Mario, whenever they use the same graphic image for the cloud as for the bush, you know, they were doing that because they had to save every single stupid pixel, or every single piece of information that they possibly could to fit it on that little like disky thing. And it's the same thing. Eventually you might get to a place where things will be necessary to worry about this, but in any case, we're just doing this so that whenever we talk to actual programmers, we don't look dumb. So basically the idea is in base 2, you're using it representing 64 bits. So like 3 is equal to 1.1 times 2 to the first. And if you don't care, that's okay. It's 2 to the first, right? Because it's 2 to the first times 1, 2 to the 0th times 1. Anyway, it's fine. If you don't care, that doesn't really matter. None of this matters except to just say that it's 64 bits. You can leave it at that. If you're like, I don't know, how does that works? There's a 0 for the plus sign. I don't know why plus sign isn't 1. It's a 0. Then there's 11 digits to represent the exponent of 1 that's on the 2. So 2 to the first, that's the 1 that goes on the first. And then there's all these digits to represent the 1.1 part. Now you're like, well, where's the 1.1? Well, because it's always going to be written as 1 point something. So we just know the 1 point something is there. So we just do the thingy that comes after the decimal place. So that's double precision, floating point, decimal. And it's okay. It can get so much worse than this. So please don't, I mean, you can Google this if you want, and please go learn things and stuff, but I'm just letting you know, like, you can like take entire classes on stuff like this and then your brain explodes and you question your life choices, and that's okay because that's what we do. All right, so anyway, the double, this is what the number 3 looks like. So if I was going to go A equals 3, this is what Matlab has somewhere in its little memory. It's like, Joop. Isn't that beautiful? It's great. Okay, so that's a lot of information. So it does, however, give us about 17 digits of decimal precision. So like I was saying, it's keeping a lot of information in there. I did not try to go figure out how pi is stored, and I'm sure I could have Googled it. I just didn't want to. This sounds like a great opportunity for you to go Google stuff. Anyway, so if I do this, if I want to look at this number, so this is the first 20 or so digits of pi, and if I look, if I print this, I get 3.14159265535 and then this says 1 2. So I get all the way to here. So everything here is correct until I get to like right there. So the 9 3 is correct, and then things start to go badly. So these numbers start to get junky. Okay, so the 9 3, see, and now you can tell these numbers are super junky. I mean, and they're not showing up as zeros. These numbers are just garbage. Matlab is giving me garbage, but it's giving me a lot of non-garbage. So 9 7 9 3. Everything's starting from here going forward after that 11,599. The 11,599 is all garbage, but those first 17 digits are good. So, you know, you can't really do stuff in programming where you're, you know, looking at 45 decimal places, because we don't have 45 decimal places of precision. We just don't have it. So, oh my gosh, so I was watching this TV show, I think it was Bones, and she was like, we are 1.577776666632159.4% sure. And I'm like, you're 1% sure, but you're like 45 decimal places sure about your precision that you're sure? Anyway, it was really dumb, but it made me laugh because I like to make fun of things. So anyway, as you can see, with saving the number 3, that's a lot of extra zeros for no reason. So there's something, of course, as you might think, called a single. So let's pretend you were writing MATLAB and you're like, why is my MATLAB code, 32 gigabytes? If you're only doing things with smaller numbers, you can just say, hey, I'm going to do this as a single. Shockingly, a single uses half as many. So it's only 4 bytes instead of 8. 4 bytes times 8 bits, 32 bits instead of 64. So it's still stay the same, except there's only 8 digits and then 23. So this is what your number looks like. Now, this is half the distance, but it gives us less than half of the decimal precision. This is kind of a big deal. So we said we got about 16, 17, 18 decimal precisions with a double, but we get less than half decimal precisions with a single. So here's all my 20 digits of pi again. And if I try to show you, my number is 3.14159, 2, and I'm already off. So I only got like 7. All these numbers here, they're already wrong. And that's because whenever it's saving all of this information, it runs out of digits to store all of that. So that's one of those things that, like, it doesn't matter if you're storing numbers like 3, 4, and 5, or if you don't really need to worry about the precision all the way out here. But if you're doing things like pi, you probably want to go ahead and store things as doubles. And again, none of this matters except for the fact that one day somebody's going to be, is that a single or a double precision? And you'll be like, I don't know what that means. And then the electrical engineers are going to make fun of you. And so you just have to know something so you don't look dumb. Kind of along the same lines, if you know something ahead of time is going to be an integer, you can save things as integers in Matlab. So I'm just giving you an example. It's called int 8. So an int 8 is 8 bits, or hold on, not 8. Yeah, it's 8 bits because it's 1 byte. 1 byte, 8 bits, 1 byte. 16 bits, 16 bits is 2 bytes, as you can imagine. 32 bits would be 4 bytes. And then 64 bits would be 8 bytes, which is the same size as a double. It's just a super precise integer. Like, it's only good for integers. It's a super precise integer. So it's pretty crazy. Now what you run into problems here is, again, when you get numbers that are like too big or too, so if I put in like 5.3, take these off so you can see what they come up as. So if I put in 5.3, see how these numbers come up as just 5. So even though I put in 5.3, it's an integer, so it just truncates it. It just completely ignores the fact, oh, it doesn't truncate apparently. In Matlab it rounds. I think in C it truncates. I don't know. Different programming languages do different things, but anyway, you shouldn't be using an int if you don't have an integer. So 2 to the 8 bits. So again, it's going to use the first digit. So there's like 8 blanks. 2, 3, 4, 5, 6, 7, 8. The first one is for the plus or minus, and then everything else is for the number. So that gives you 7 digits for the number, because the first digit is for the plus or minus. So your max number that you can make is 2 to the 7. So the max number you can make with that one, so is I think 128. I'll pull this over again so you can see. Okay, so the maximum that you can make there is 128. I think this one, again, you have 1 digit for the sign, so you have 15 digits for the number, so whatever 2 to the 15 is, 32,768. Anyway, so you're kind of getting the point. So if I put in like 128, because it's -1, I suck at remembering things, because it can't quite get to the max. So if I put in 127, this guy can totally get to 127. See 127? All these guys are 127. But if I put in 128, this guy's like, did you mean 127? Because that's the biggest number I know. So if I put in 200, it's like, this is the biggest number, 127. I'm gonna actually put these back on because I think this is a little hard to see. So anyway, there are some interesting things, and I use interesting in quotation marks, that you can do with data types. So if I put in a giant number, so even though I'm putting in the same number, let's let's see how many digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. I'll do that a couple more times. So obviously I made this one explode, so H eventually got tired. This one eventually got tired. These all got tired. How many did I say? 8 bytes? Oh, so the biggest number I could do was 2 to the 63 minus 1. Oops. 2 to the 63 minus 1. So the biggest number would be 9 times 10 to the 18th. I'm clearly way past that. 9 times 10 to the 18th. That's not 18 either. It's 20. Okay. So anyway, just kind of playing around, you can see how 1, 2, 3, 4, 5, 6, 7, 8, 4. So there's where some garbage comes in. Anyway, so you can just kind of play and see that you run into the biggest number this guy can possibly be is 127. There are also unsigned integers. There's all kinds of stuff you can do. I think I've officially lost everybody's interest except for the super dorks, who probably already kind of knew some of this anyway. But it's kind of neat. And then just as a thing, if you know something's going to be true, false, you can specifically save something as a Boolean. If you say something is true, see, it saves it exactly as 1 byte. So if you instead say n is 1, it's saving it as 8 because it's assuming it's a number. If you actually use the word true in MATLAB, it'll save it as a byte, true or false. See how it says it's logical. False. So you can save things as a true or a false specifically so that you know you're saving space. So that is about as I can't even say exciting. That is as exciting as this is ever going to possibly get. So I mean, if you want more, there's more, but yeah, that's good.